Good morning, guys. Good afternoon, guys, and good evening, guys, across the world. So today we're going to discuss about containers. So before discussing what is containers, let me give an explanation of why we're going to discuss about today containers. So whenever we're going to have a discussion with any software developers or any software architects or any software related folks, we keep hearing the word, very common word named containers. Okay, on Kubernetes. So before going into Kubernetes, I would like to have an session on containers that makes a clear visibility of that makes a clear understanding of why Kubernetes is required at first. Okay, so let's start now with containers. What is containers and why containers? Okay, so before here going to start with containers, I would like to give an simple explanation of what is virtualization is. Okay, so assume I'm going to buy or purchase, or my enterprise, my company is going to purchase a virtual, my company or my enterprise is going to purchase a bare metal physical server. Okay, on that which I will be having my hypervisor. So what is hypervisor? So hypervisor is an hardware virtualization technology through which you can build many virtual machines on top of this physical bare metal server. Assume for example, my physical bare metal server is of 100 GB RAM and 100 GB of storage. As a layman example, I can virtualize my physical bare metal server into four virtual machines. For example, each virtual machine of 25 GB RAM and 25 GB of storage. Likewise, it can be we can build four virtual machines on top of it. Okay. So assume this there is one VM. What I you guys can see here, I have highlighted here as one virtual machine. What I'm going to build, for example, 25 GB of RAM and 25 GB of storage. Guest operating system. Assume my developer is planning to develop a Node.js application. So for the Node.js application, he would like to have an guest operating system. He need to have an Linux operating system, for example. The guest operating system would be a Linux operating system, and his application is going to be Node.js application. And what are all the libraries and binaries that is required to install this Node.js application would need to be installed as binaries and libraries to support that Node.js application. On top of that, you can see I have highlighted application B. This application B is what the developers would be writing their application code to develop a Node.js application. So now this is in my virtual machine. Now what the problem we see here in virtual machine is when developing application. Assume this as highlighted one as development environment. Okay, and the next tab C, right, that might be in virtual machine what I have built it for my UAT environment, my staging environment. For example, if I need to move my piece of code from VM for development to VM to UAT or staging, the same operating system I need to install it here again. The same binaries, libraries, what I've installed in the previous VM to be installed here, and my application code need to be need to be copied or checked into my VM, my previous VM to the new VM. That is from my development environment to my UAT environment or staging environment. Okay, by doing this, okay, there can be some missing of libraries or issue of binaries and libraries or some different versions. So because of this, the application which was working fine in a development environment might have a chance of not working properly in your UAT or staging environment. This is one issue. And the second issue is uh, assume I'm developing my application in my local machine. I might have a Mac OS machine, my local desktop, and it might be Windows as well. Okay, so the libraries what I am going to install in my, for example, in my Mac OS machine and develop a Node.js application, and I need this Node.js application to be deployed into my enterprise or company's server. That might have a different operating system, might like Linux or Windows. Okay, so when I'm going to do the same code deployment there might be a problem with the dependencies or libraries because that operating system might be Linux or Windows, and the application where I have developed might be of Mac OS, and there might be some dependencies which conclude saying that problem statement is my application is running fine in my Mac machine, but when I host or I deploy that into my Linux or Windows in my data center or in my cloud, it doesn't run. Okay, to avoid these kind of discrepancies is only we have started to discuss on the containers concept here. So what is containers now? Okay, so let's split this containers into two portions, from the hardware perspective and from the infrastructure perspective and from the software perspective. So I'm going to have the same physical bare metal server. In that I'm going to install my host operating system. On top of that I might install, I need to install the Docker. Okay, so once I install the Docker, okay, I can use the containers concept there. Okay, so this is just to park this idea aside. Now let's come into understanding of what is containers in high level. A container is nothing, a method to build, transport, or run the application across multi-lighter weight format. Okay, so basically, when I'm going to develop an application in my local machine, okay, if I'm going to have a Docker and build the application in a container fashion, okay, I can wrap my binaries, libraries, application code into a single file or into my single deployment model where it is portable across many environments. For example, the same scenario what we discussed earlier. I might have a Mac OS machine. I might develop a Node.js application. Okay, so if I'm going to install Docker in my machine and I'm going to containerize my application, once after it has been developed, I can build it as a container image. I can build it as a Docker image. So Docker image is nothing but it would wrap the all the uh, supportive or necessary binaries, libraries, and application binaries or application code into a Docker image. So this Docker image can be shipped or transported across environments like dev environments or staging environments or production environments without any dependency. It can run seamlessly. And moreover, it can be even developed in a local Mac OS machine, and it can be portable across the servers in different environment of different flavors as well. So this gives an understanding of why virtualization is way behind than containers, because it abstracts the dependencies. This is the very thin understanding of. Okay, so now let's go into next step. Okay, I was keep on using the word what is Dockers. What is Dockers? Okay, has become synonymous with container technology because it has been the most successful or popularizing in containers world. Okay, and by the way, container is not new. Okay, container has been almost a decade in the industry, where Linux is in the form of LXCs, and same for AX and same for Solaris as well. It was been a long time in the market. As I told, let me give a very brief explanation here. With Dockers, you can a developer can create, deploy, and run application in containers. A developer to package up an application with all the partners, libraries, and containers, and ship it all out as one package across different environments and different platforms. Okay, so, and you can see this here. This is a very simple. Docker can build images automatically by reading the instruction of Docker files. Blah blah blah. You can see it here. Okay. So let me give an raw example. Take I'm developing an application that is having that is going to be deployed on three environments: Dev, UAT, and Prod as per my enterprise standard. So for Dev, let me say this is the Dev virtual machine. This is my UAT virtual machine, and this is going to be a prod virtual machine. For Dev virtual machine, I need to install operating system, and I need to install, for example, Node.js application, all the dependence binaries, and then all the application would be developed here. And this would be checked into my GitHub. From my GitHub, I would be pulling that to my UAT and that to my prod. Before pulling that, I need to install the same guest operating system and my exactly the same application specific binaries here and this environment as well. So by this, if my application, once I am going to pull it from a GitHub and going to deploy it and run it here, there are chances of my application might not be running properly. The reason behind there might be some dependencies issues, this kind of issues. As I told before, to avoid these kind of things, we have moved into a concept of containers. So let's now discuss how does this container works. So before this containers, how is going to work here, I already given an explanation of what is containers is. Here you can see three new terms displayed in the image here, saying Docker image, Docker file, Docker hub. Okay, so let me give an explanation of what is Docker file. Okay, so you see I have provided a sample Docker file here. This is my sample Docker from Node 7. So I will have some few lines in my Docker file. We can see that from Node 7. So what does this statement means? We'll use the official Node.js image with the Node 7. So basically this statement in the Docker file will download all the Node.js image to build our application. Okay, and the second line here, what I have highlighted here is work directory slash app. Okay, by this what I'm defining here is I'm setting the working directory in the container to slash app. We'll use this directory to store files, run npm, and launch our applications, so on. Okay, And the next few set of lines, what I'm going to use here is copy package.json slash app run npm install copy slash app cmd. Okay, these three commands particularly. So what these commands does is it will copy the application to slash app what we have created earlier in our step. Okay, and it will install the necessary dependencies with this command run npm install. Okay, so this is very clear. Now we have our application made a copy to our slash app directory in our container, and we are installing the Node.js respective installed respective binaries using this command. Now the binaries is ready, and then we have application code is also ready. Okay, so the final command is cmd node index.js. What this command does exactly is, okay, this would be what should be executed when the docker image is launching. When my docker image is going to launch, what should happen? Okay, this is what our application runs. So I will come back to explain what docker image in a short while. Next is the command expose 8081. Okay, what does it does? So now my application has been launched into its container. Okay, and this application need to be exposed to the outside world. Okay, that is to a particular port. So I'm exposing my application through from a container through one particular port named 8081. Okay, through which my container has been launched. So this is my sample docker file. So to wrap it, this sample docker file, with that I can specify which application programming language I'm going to use it, and I can download all these necessary programming language binaries into my containers. On top of that, I can have my application to wrap it as a Docker image. Now let me come to what is Docker images. So now all my application specific Node.js libraries, binaries, and my application code, everything has been encapsulated into a single image. Okay, that image is known as a Docker image. Okay, so my application has been built into a Docker image. So what is Docker Hub? So this image, okay, need to be stored somewhere where I can push it to a secure environment, and where I can pull it to a different environment in my UAT or prod to run it. Okay, so I need a consolidated centralized environment where I can store my applications image, that is I am naming it as Docker image. So this is the Docker hub where my images has been pushed here, and my UAT environment, a product environment, can pull the same image to run it. Okay, provided we need to have a Docker installation here. Okay, so likewise the application can seamlessly run from dev, UAT, and prod. So this is very simple explanation of what is Docker hub, what is Docker file, what is Docker image, and how containers is better than virtualization. So this should have given you a brief explanation or brief introduction of what is containers. So stay tuned guys for our next Kubernetes sessions. So with that Kubernetes session, we will be seeing how to build a Kubernetes application, sample application, how to orchestrate the containers with Kubernetes in the following video. Thanks for watching. Have a nice day. Bye bye.